If you go on substituting the value as 1, 2, 3, you will get a sequence of even numbers only. If you divide 24 by 12, you will get 2. So this is nothing but a common ratio or common multiples between the next terms. Suppose you have r as greater than 1. Then you can use this formula to calculate the sum of geometric progression. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we'll be starting up with the new chapter, Sequences and the Series. So let's see what are the concepts we are going to study in this session. So first you will get an introduction about the sequence and series of numbers. Next, so whenever r is less than 1, you can use this formula to calculate the sum of the sequences. Whenever r is greater than 1, you can use this formula for the calculating the sum of the geometric progression. We are going to study about these two, arithmetic and geometric, in terms of sequences, series as well as mean. So let's see what do you mean by sequences. A sequences are nothing but the arrangement of numbers. For example, when I say the sequence of even numbers, your sequence will be 2, 4, 6, 8, etc. like this. Suppose when I say the sequence of odd numbers, then 2, 3, 5, 7, 11, etc. So when I say the sequence of multiples of 4, then you can take 4, 8, 12, 16, etc. So these arrangement of numbers are nothing but the sequences. Here the domain will be always the set of natural numbers. So the sequence are considered to be a function whose domain or the set of natural numbers, or you can say any subset of natural numbers. Now, we denote these terms. In general, we denote the terms of sequences as A1, A2, A3, etc., AN, etc. So, you may get infinite number of sequences, that is infinite number of numbers you may get. So, here A1, A2, A3, etc. are the first, second and the third terms, and AN is the nth term, and you may get the numbers after nth term also, that is n plus 1th term, n plus 2th term until infinity. So now whatever the nth term, we said it as AN. So the nth term is usually denotes the arrangement of that sequence. It is called the general term of the sequence. For example, for an even number, I can write AN is equal to 2n. So, n may be any natural number. I said n belongs to the set of natural numbers here. So, if you go on substituting the value as 1, 2, 3, you will get a sequence of even numbers only. For an odd numbers, you say AN can be written as 2n minus 1, here n belongs to n. So when you start with 1, it is 2 minus 1, 1. When it's 2, it is 2, 4 minus 1, 3. So like this, you will get 1, 3, 5 until an infinite sequences. So for specific sequences, you have nth term. But you can observe here, I have also given an example of sequence of prime numbers. So here, in the sequence of prime numbers, you are not getting any visible pattern to recognize. So, for some sequences, you are not supposed to get the general term. Only for few sequences, you can generate all the terms using nth term. We also have one sequence called Fibonacci sequence. So, Fibonacci sequence or Fibonacci numbers, or you get, so first number or 1, second number is 1. The rest of the numbers you are getting by adding the next two numbers. So that is 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13. So these are called as Fibonacci sequences. So here usually we write, this is the arrangement of numbers. The nth term can be written as an plus an plus 1. So for example, this is, if you put 1, it is a1 plus a2. a1 is 1, a2 is 1, you will get a3. If you want a4, it is a4 plus like this. So when you go on adding the terms of a particular term to the next term, you will get the Fibonacci arrangement. That is called as Fibonacci sequence. Hence, what we can conclude here is, a sequence can be regarded as a function whose domain is the set of natural numbers or some sets of it. And it is always denoted by a of n or an. So, like this, we can arrange or we can write any set of sequences representing in the form of an. Hence, sequences are considered to be a function whose domain is always the set of natural number or any subset of natural numbers in the form of 1, 2, 3, etc. until k. Next, we come across series. So, what do you mean by series? I already said you that numbers are arranged in terms of a1, a2, etc. until an, and after that also you may get some arrangement of numbers. So, adding all these numbers is nothing but series. Suppose you have a terms like a1, a2, a3, etc. an, then the addition of all these number, or we call it a summation. So, summation of all these number is called as series. It is denoted by sigma an. So, here this is called as sigma, which denotes summation. That means you should add all the numbers from 1 to n. Suppose you have 2, 3, 4, 5, 6. So, these are the terms a1, a2, a3, a4, a5. Then you should add all the numbers in the form of an. Here n values varies from 1 to 5 because you have only 5 terms. So, n is from 1 to 5. So, that means you are adding a1, a2, a3, a4, a5. So, when you add this is equal to 20. So, this is called as the series. So, adding the sequences or taking the summation of the sequences or nothing but the series. Next, we come across arithmetic progression, which is also called as AP. So, progressions are also nothing but sequences. What do you mean by this arithmetic sequence or arithmetic progression then? So, if you have a sequence in the form of a1, a2, etc., an, then arithmetic progression, we call the sequence as an arithmetic progression if an plus 1 is equal to an plus d. Here, d is called the common factor. For example, I'll give you, so 2, 4, 6, etc. So, this is an arrangement. So, here you have the next term you got by adding some common factor. So, clearly when you add 2 to this, you will get 4. Again, when you add 2 to this, you will get 6. Again, when you add 2, you will get 8. So, here 2 is called the common difference. Not common factor, it is called as common difference. So, when you add common difference to the next number, you will get arithmetic progression. So, for example, 4, 8, 12, 16. So, how you get, when you add 4 to these numbers, you will get the next number. So, these type of sequences are nothing but the arithmetic sequences. So, when you have any number and when you have a common difference to add to get the next number, the resulting sequence are nothing but the arithmetic sequences. Let's see now. In general, the terms of AP can be written as A. If the first term is A, then the next term is A plus D. The next term can be written as A plus 2D. You can guess here. So, it is 4 plus 4, the next term. Next is 2 times 4. 2 4s are 8. So, when you add this can be written for the first term. If you add 8, you will get 12. For the second term, if you add 12, that is 4 3s are 12, you will get 16. So, keeping the first term and common difference, by adding the multiples of common difference, you will get the next term. So, if this is A1, A2, A3, then this will be your next AN term. So, like this, we are going to write the sequences in arithmetic progression. So, here A is called the first term, D is common difference, N indicates the number of terms. So how many number of terms they'll ask you to write? You are supposed to arrange it in a arithmetic sequences. Next, the last term or the nth term of an AP can be written as AN or L. L may indicate the last term, otherwise we will write it in the form of AN. It is usually given by A plus N minus 1 into D. Next, the sum of the n terms of AP. I said when you add the sequences, you will get the series. So when you add these sequences, you will get the summation Sn of arithmetic progression using the formula n by 2, 2a plus n minus 1 into D here you should write. So we have n by 2, 2a plus n minus 1 into D is the formula to find the sum of the arithmetic progression. Suppose if you know the first and last term, then the sum of the arithmetic progression can be written using this formula, that is n by 2 into a plus L. Next we come across the arithmetic mean of a number. So here arithmetic mean is nothing but average of two numbers. We know that average is nothing but sum of all numbers divided by the total numbers. So here you have only two numbers. So arithmetic mean of any two numbers A plus B is given by A plus B by 2. Suppose you have two terms 3 and 11. So how you will find the arithmetic mean? So AM is given by 3 plus 11 divided by 2, that is 14 by 2, which is equal to 7. So 7 is the arithmetic mean of these two numbers. Next, we are coming towards the geometric progression, also called as geometric sequences. How these sequences are arranged. So in arithmetic progression, so the first term and the next term differs by a common difference. Here, the first term and the next term differ by a common ratio. That means you have some common multiples for it. Now, let's see a sequence A1 to AN is called geometric progression if AN plus 1 by AN is equal to R. So, here N is always greater than or equal to 1. So, the first and the next term or the second term and the first term will have a common ratio or a common multiples between that. So, we can take an example for 3. So, here I'll write 6. So, next I'll write 12. Next I'll write 24, etc. So, here you can see AN plus 1 by AN means the next term divided by the previous one. So, if you divide 6 by 3, you will get 2. If you divide 12 by 6, you will get 2. If you divide 24 by 12, you will get 2. So, this is nothing but a common ratio or common multiples between the next terms. So, here you will get this sequence by dividing or by getting the ratio. So, you have a common multiples for this. So, this sequences are nothing but the geometric progressions. So, now how the terms are arranged here. So, they are arranged in the form of AR square, ARN minus 1. R is nothing but the common ratio, A is the first term and N is the number of terms. I can write this like this. Here first term is 3, second term can be written as 3 into 2, third term can be written as 3 into 2 square, fourth term similarly you can get, and the last term can be written as 3 into 2 power n minus 1. N depends on the number of terms they have provided. So, here you can see 2 square is 4, 4 3 is 12. So, you will get this as a sequence which is called as the geometric progression. Now, the nth term of the GP can be found using the formula AN is equal to AR n minus 1. N depends on the number of terms. Next, the sum of n terms. So, suppose you have a two formulas here, very easy to remember. Suppose you have R as greater than 1. Then you can use this formula to calculate the sum of geometric progression, that is A into R to the power n minus 1 by R minus 1. Now, I may get few sequences like 24, 12, 6, 3, etc. So here if you divide the second term by first term, here you will get the ratio as 1 by 2. So 1 by 2 means it is less than 1. So whenever r is less than 1, you can use this formula to calculate the sum of the sequences. Whenever r is greater than 1, you can use this formula for the calculating the sum of the geometric progression. So usually we write Sn is equal to a into r to the power n minus 1 divided by r minus 1 to calculate the sum of n terms in a GP. Next is geometric mean. Suppose you have any two numbers a and b. Then the square root of multiplication of those two numbers are nothing but the geometric mean, and it is given by g. So suppose you have 4 and 6. What is the geometric mean of 4 and 6? G is equal to square root of 4 into 6, which is root 24, or you can write this as 2 root 6 clearly. So you can get it from here itself. So 4, when you take it out, you will get it as 2. So 2 root 6 is the geometric mean between the two numbers, whereas the arithmetic mean is nothing but average of two numbers. Geometric mean is the square root of the product of two numbers. Next, what is the relationship between this arithmetic and geometric mean? Here I have concluded arithmetic mean is always greater than or equal to geometric mean. Let's take an example. Let me calculate the arithmetic mean and geometric mean between the two numbers 4 and 16 now. So let's calculate the arithmetic mean. Arithmetic mean is 4 plus 16 divided by 2, which is 20 divided by 2. Here you will get 10. Let me calculate geometric mean. It is root of AB, which is nothing but root of 4 into 16, which is 64, which is equal to 8. Clearly what you can observe, A is greater than G. Sometimes you may get A equal to G also. So therefore I have written the symbol A is greater than or equal to G. So for any two numbers, arithmetic mean will be always greater than the geometric mean. So this is the relationship between the arithmetic mean and geometric mean of any two numbers. So these are the important definitions of the chapter, series and sequences. You should know what do you mean by arithmetic progression, geometric progression, sum of n terms of AP, sum of n terms of GP, and arithmetic mean and geometric mean. So let's take few problems related to the concepts now. The very first problem here is, write the first three terms in each of the following sequence defined by the following. So they have given a sequence here. We are supposed to write the first three terms. That means A1, A2, A3 we need to find out now. So they have given an is equal to 2n plus y. Let's substitute for a1. Then it is 2 into 1 plus 5, which is equal to 7. Next we'll take a2. It is 2 into 2 plus 5, which is 4 plus 5, 9. Next a3, 2 into 3 plus 5, which is 6 plus 5, which is 11. So therefore, the sequence will be of this form. 7, 9, 11. So clearly you can observe this is an example for arithmetic progression because you have a common difference of 2 between two terms. Next, an is equal to n minus 3 by 4. Let's see now. A1, 1 minus 3 by 4, which is minus 2 by 4, which is equal to minus half. A2, 2 minus 3 by 4, which is equal to minus 1 by 4. A3, 3 minus 3 by 4, which is 0 by 4, which is equal to 0. So therefore, the first three terms are minus half, minus 1 by 4 and 0. I clearly said n belongs to the set of natural numbers. So the domain of the sequences are natural numbers. It is not that range should also lie in natural number. Only the domain of the sequence are in the set of natural numbers. You may get the negative numbers or 0 as range. Next, What is the 20th term of the sequence defined by an is equal to n divided by n plus 1? Here we are supposed to calculate only the 20th term. So therefore, A20 is equal to 20 divided by 20 plus 1, which is equal to 20 by 21. So this is the 20th term of the given sequence. Next, write the first 5 terms of each of the sequences whose nth terms are. We are supposed to write the first 5 terms, A1, A2, A3, A4, A5. Let's write it. The given question is an is equal to n into n plus 2. So A1, 1 into 1 plus 2. A2, 2 into 2 plus 2. A3, 3 into 3 plus 2. A4, 4 into 4 plus 2. A5, 5 into 5 plus 2. So here we can write this as 1 plus 2, 3, 3 into 1, 3. 2 plus 2, 4, 4 2 is 8. 3 plus 2, 5, 5 3 is 15. 4 plus 2, 6, 6 4 is 24. 5 plus 2, 7, 7 5 is 35. So therefore, the first 5 terms are 3, 8, 15, 24 and 35. So these are the first 5 terms of the given sequence. Next, an is equal to n by n plus 1. Clearly we can write this as a1 is equal to 1 by 1 plus 1 means 1 by 2. A2 is 2 by 3. A3 is 3 by 4. A4 is 4 by 5. A5 is 5 by 6. So clearly, because this is in the form of n by n plus 1, so we can directly write the terms as 1 by 2, 2 by 3, 3 by 4, 4 by 5 and 5 by 6. So these are the first 5 terms of the given sequence. Next, an is equal to minus 1 whole to the power n minus 1, 5 to the power n plus 1. So remember that minus 1 will be 1 if the power n is even, and minus 1 whole to the power n will be minus 1 if n is odd. Or I can write any power. So I'll write here p. So p represents the power. If p is even, then you can write minus 1 as 1. If p is odd, then you can write it as minus 1. So let's see now. A1 is minus 1 whole to the power 1 minus 1, 5 to the power 1 plus 1. A2 minus 1 whole to the power 2 minus 1, 5 to the power 2 plus 1. A3 minus 1 whole to the power 3 minus 1, 5 to the power 3 plus 1. A4 minus 1 whole to the power 4 minus 1, 5 to the power 4 plus 1. A5 minus 1 whole to the power 5 minus 1, 5 to the power 5 plus 1. So here 1 minus 1 is 0. So anything to the power 0 is 1. So here it is 5 square. Here it is 2 minus 1, 1. If power is odd, you can write it as minus 1. Here it is 5 cube, so it is minus 5 cube. Next here 3 minus 1 is even, so it becomes 1. And here it is 5 power 4. 4 minus 1 is odd, so it is minus 1. So it is minus 5 to the power 5. And here it is 5 minus 1, which is even, so it is 1. 5 to the power 5 plus 1 is 6, so it is 5 to the power 6. So therefore, the sequences are 5 square, 5 cube, minus 5 cube, 5 power 4, minus 5 power 5, 5 power 6. So these are the first 5 terms of the given sequence. Next, find the indicated terms in each of the following sequences whose nth terms are given. So they'll give you the value of n. We are supposed to calculate only the given term of the sequence. So the first problem is an is equal to 4n minus 3, a17 and a24. We are supposed to calculate only the 17th term and 24th term. So let's see a17. It is 4 into 17 minus 3. So it is 68 minus 3. So a17 will be equal to 65. Next term they have asked you a24. So it is 4 into 24 minus 3. which is equal to 96 minus 3, that is equal to 93. So these are the given terms. So the next question, an is equal to n square by 2 power n. Given term is a7. So let's calculate a7. a7 is equal to 7 square divided by 2 power 7. So you can cancel it or you can write the answer 2 power 9 divided by 128. So this is the answer. So the next question is, write the first 5 terms of the sequences and obtain the corresponding series. So they have given a1 and an is equal to 3an minus 1 plus 2 for all n greater than 1. We are supposed to calculate a1, a2, a3, a4, a5. So look at the condition here. You should take n greater than 1. So you can't take n is equal to 1. So you should take n greater than 1. And remember, n belongs to the set of natural numbers. So you can take only 2, 3 like that. So let's take a2. So a2 is 3 into a2 minus 1. Here it becomes a1. So which is 3 into, what is a1 given here? 3. So 3 3s are 9. Next a3. a3 will be 3 into a2, which is 3 into 9, 27. Next a4. 3 into a4 minus 1 is 3. So it is 3 into 27, which is equal to 81. Next a5. 3 into a4, which is 3 into 81, which is 243. So therefore, what are the first 5 terms? So therefore, the first 5 terms are 3, 9, 27, 81, 243. So clearly this is a geometric progression. So when you divide the previous term with the next term, you will get the common ratio 3. Next, a1 is equal to minus 1, an is equal to an minus 1 by n is greater than or equal to 1. Since a1 is already given, let's calculate a2, a3, a4, a5. So let's write a2. a2 will be a2 minus 1 is a1, n is 2. What is a1 given? It is minus 1 divided by 2. Next a3 will be a2 by 3 because n we have taken as 3. So by n means 3. What is a2? Minus 1 by 2 divided by 3, which is equal to minus 1 by 6. Next a4 is a3 by 4. So which is minus 1 by 6 divided by 4, which is equal to minus 1 by 24. Next a5, which is a4 by 5, which is minus 1 by 24 divided by 5, which is minus 1 divided by 120. So now we have got the first 5 terms. So what are the first 5 terms? We have minus 1, minus 1 by 2, minus 1 by 6, minus 1 by 24 and minus 1 by 120. So these are the first 5 terms of the given sequence. So in this session we have learnt about the 2 types of progression, arithmetic and geometric. Also we have analyzed how to write the given sequences whenever the conditions are given. We'll take up few more problems in our next session. Until then, keep watching, keep learning and keep exploring. Thank you.